the Allwett models. How to find the PDE of Allwett model? So the Allwett model is just extension of facet model. So you're going to start by guessing, which we have to know TPT, which is equal to exponential raised to a t minus t minus b within bracket t minus t, or which t minus t is equal to tau. So that means t minus t is equal to tau, which is equal to g t rt. So we are going to take the drift term of facet model, which looks like this one, changing over changing t dt plus changing over changing rt. Then we substitute this one. Remember, here we are using the Ito's lemma. Plus a half second derivative of this one then sigma squared plus minus determinant factor rt g dt. So after this one, so we have this one p in the bracket dt, t capital T is equal to this one, which is equal to this one. So from this point we can start by differentiating this one, which looks like this equation. So we can say over changing t is equal to g t rt in the bracket. We differentiate this part in respect to t, changing t minus t over changing t minus changing, but remember, here we have rt, so changing b t minus t over changing t rt. When we come here, we differentiate with respect to this one, with respect to rt. We are going to get negative g t rt b tt, because this one doesn't have rt, but this one has a rt. So second derivative of this one we are going to get g t rt b squared tt. So here we have this one, this part, and this part of the Ito's lemma. So we are going to, because already we have g t rt is common, we can see, we can factor out GRT then we start with this one, changing a t minus t over changing t minus changing b over changing t. That was first one, plus minus b tt, then times, because already we have drt is equal to this one. This one is, this part already has drt is multiplied by this one, we multiply by this part, mu t minus rt plus a half b squared tt times sigma squared, this sigma squared, plus determinant factor, which is rt plus rt g t rt dt, or we can ignore dt. We can ignore dt because determinant factor should look the same way as this one, because we already have differentiated this one, so we have to ignore the dt. So from this point we can say g t rt, we can change this one to be a t t, this one to be b prime t t. So I'm going to get a prime t t minus b prime t t, but capital T rt minus b t t in the bracket alpha mu t rt plus a half b squared sigma squared t t plus rtg trt. Because this one has rt, we can put it inside here, so that we can get g trt. We can start with rt, we can factor out rt, then we start with this part has rt, this part, then mu that one. When we open the bracket here, remember we have a bracket here, it becomes alpha mu t minus alpha negative alpha rt. So negative alpha rt times negative b, that one, we get positive, so we get alpha b, because we have factored those rt, then we get t t minus this one b prime t t, then we have this one, we factor out this one, this rt, but already we factored those g t rt, so we get plus, not plus, we have done mistake, this one is minus, so it's equal to minus 1, then plus a, this part t t plus a half sigma squared b squared t t, then you close the blanket, which is this one is equal to 0 because this one is a drift term. Thank you. That is the process how to find the PDE of the hull weight.